Good afternoon, everyone. Today I'll be talking about virtual prototyping and development of robotic devices. Basically, I'm studying the principle and the concept behind virtual prototyping, and to find out how it gives us the flexibility of analyzing different difficult systems in an easier way. It basically went from from a simple pendulum, as you see earlier. So I'm not going to go over most of what my colleagues went over. Just going to give you the basic implementation of it. But so in the background, I'm going to talk a little bit about the benefits of it. Just touch on the software, the implementations of it. Talk about some applications, the case studies, and finally my conclusion. Basically, virtual prototyping, as I expressed before, is it emphasizes the use of parametric designs which are refined by interfacing with analysis and manufacturing simulation tools. It basically gives you a concept or a new way of designing old things in a more efficient way. Some application of virtual prototyping is basically computer animation, which you see over there. You can simulate a person and in a robotic way, which is one of the ideas behind the simple pendulum or the pendulum. The rotating knee is an example of a pendulum, the movement. So it's the same concept in robotic, it's just a reverse direction. In architecture, I mean, you have the building, the design and modeling of a engine block there, and you have the Mars rover, which is also uses the same concept of virtual prototyping. What are some of the benefits of prototyping? Well, engineers are able to fine-tune design before they are manufacturing, before they build a physical prototype. You have a basic suspension system up there, and you have a Chrysler 300. It improves the product design and lower development costs. For example, with the Chrysler 300, and you see a virtual prototype of just the suspension system right here. Oh, imagine driving down the road and the car bumping. If they didn't have a full idea of how to build a suspension, before they used to have to build a lot of these cars and, you know, constantly running them through tests. But nowadays, what they do is build the virtual prototype and put it through computer system, run the finite element analysis on it, and simulate the movement in every possible direction, and then create a better suspension system. Again, some of the software that they use, you already see this before, so I'm not going to go over that. Implementation basically goes in several steps. You have the modeling, which I expressed before. You have to create mathematical analysis. You have geometric, you have the kinematic and dynamic parameters that you have to first come up with. Then you go to the simulation stage, which is putting all the information into the computer. You get a visualization, which is basically a graph. After you create a solid model of the system, you get an output. Then you go to simulating mathematical models. From learning what you can learn, you have the numerical solution as a function of time, which you create from the mathematical model. You analyze the dynamics of those behaviors. Then you have the 3D model, which you get, again, you put it in and you do. That's basically the skeleton of my project. It was not fully completed because of time, because it was a difficult one. Right. These are some of the basic applications and the benefits of virtual, like Michael asked before, Matthew rather, what are the difference between the approaches? You have the virtual approach, you follow a basic cycle of fixing. It goes from the concept design before, you have the building of the virtual prototype, you have the measuring of performance, and it goes through that. So it goes through the cycle, and then if the criteria is met here, you keep going. However, if it's not met, you have to constantly going back in the cycle. This used to cost money. That's where the money used to come in, where they talked about earlier. Now, in the virtual approach, sorry, this is the virtual approach, the conventional approach. This was the conventional approach and the virtual approach. So the virtual approach costs less money. Basically, like the express, so some research goal was, mine was we basically were to gain exposure and understanding of the research method using virtual, but be able to apply and communicate what we learned during the process. And for my project, basically, even though it utilized, even though we studied all the system, mine basically focused mostly on the 4-bar mechanism. How does that relate? If you look at the skeleton of the truck, it had suspensions, then they had loops. The 4-bar mechanism is basically a loop equation. It's a closed loop. It could be 5 bars, 6 bars, but it's a closed loop. That's why it's considered that type of mechanism. Again, these are the case studies, and this is the prototype of my model that it built. Basically, it built from the simple suspended wheel, the frame, and the construction of it to the final product. This is basically what I showed before, the graphical analysis of this, the system. This was for the 4-bar, which is, no, not the 4-bar, I think. It was the 4-bar. The 4-bar, yes. We talk about getting the frequency, and as I expressed before, the difference as you go higher in frequency. And there's the difference in values. You receive the percentage error increases. So basically, by using prototype, you apply the knowledge of different case studies, you analyze the kinematics and dynamics of the behavior, you get a numeric solution as a function of time. And there's a detail of some of the steps. Again, the mathematical, you have, this was what I had, was supposed to simulate. It had more intricacies, like you can see, you know, a lot of bars, a lot of different shapes to it. And so in conclusion, I was supposed to complete the virtual prototyping of the truck. It's an RC truck, which would have ended up looking similar to the model over there with the suspension system built in, so we could put it through the same set of steps and create the mathematical calculations from it. Again, like I told you, some of these calculations are very rigorous. It takes a lot of time, so you know, you can only do so much by hand. You'd have to put it in a computer, in a software program like MATLAB or something like that to get your final answer with, you know, a lot of degree of freedom because it has the pendulum, the angles, and so forth and so on. So in completing this study, I'd like to thank everyone who contributed to the CSTEP program, my research mentors, and CSTEP interns. Thank you.
You actually finished it? Or what? And you did mention it. So.
No, I didn't complete that. I just finished the skeleton model of it. I did not complete as we expressed. We only got up to a certain point because in 5 weeks you cannot do the entire modeling and simulation of this thing. Because again, the mathematical, the kinematics and dynamics that goes into the completion of it takes a long time. And again, this is normally taught in a course over some, you know, over a period of months. Take a class in it. We just got thrown in it, and for 4 weeks you couldn't possibly. But we could have completed the simulation model in that period of time. I would understand it.
My question actually was, can you go back and couple of slides? That, yeah. You see that car right there? That's actually in the market because people use that already.
Yes, but however, what this is going to be end up using for is something like Mars rover that it's an actual marketed car, but they're
I didn't finish my question though. I was saying that's in the market, so that's fine. So are you coming up with a better product, one that's more efficient, cost effective, than the one which is already in the market?
Basically, what you're doing, you're customizing something that's in the market to do something different.
The same stuff.
Yes, so customize it to do something different. For example, like the Mars rover, something that could actually analyze, you know, for example, the Mars rover goes to Mars and it tests its terrains, and if it's going to run up to, you know, on a wall or something, it's able to detect. So basically, we put in it through modeling that we can actually do that sort of thing.
I know that you were actually using the product tested virtual prototyping program.